Hi, I'm Sebastian, and this video series will be all about this awesome machine right in front of me. What you see is the LEGENDARY R960 SME, handmade by PREMACON Germany. The model is produced under the license of LEGENDARY and it's scaled in 1 to 14.5. This model is completely remote controlled and it has about every function like the big one. So all the hydraulic cylinders are operated with real hydraulics, the tracks and the swivel drive are operated with electric motors. You have all the lights like the big machine, and last but not least there is a sound module with the sound of the actual real machine. The model can be ordered either as a completely built up piece like it's standing in front of me or as a kit, and that will be what we are looking at in this video series. So come share the experience with me of building such a kit, from all the individual items to the finished product in the end. Before we start, a little disclaimer. As some of you might know, I'm actually part of the company PREMACON, and therefore I know about every little screw of this model. And if you already got one for yourself, I was probably involved in the process of making it. But I won't be using any fancy tools or techniques during this build-up. I want to build this model exactly the way like you can do it at home, and I want to share the experience of getting from all the individual items to this completely built up kit. So without further ado, let's take a close look up at all the details. All right, folks, before we finally start building the model, let's talk briefly about the tools used and needed. I get asked quite regularly what tools you need or should buy to build a model like this. Of course, this is also a matter of personal taste and how much good tools are actually worth to you each individually. Personally, I only use or try to use high quality and brand name tools for building models like this one. In the beginning, of course, I also started with many different tools that were just like laying around. But believe me, at the end of the day, good and consistent tools will save you a lot of headaches and make your day much, much easier. So let's quickly go through the tools that I personally use. And of course, for more information, you can always find the list of all tools used in the video description. And by the way, just feel free to write in the comments which tool you can't live out anymore, or which tools do you prefer to use. So all the tools that I'm about to show you are just my personal preference. Nothing is sponsored by any tool manufacturer, so it's just a list of things that I like to use. So let's start with the most obvious tools, screwdrivers. I'm sure you all already have them, so there's not too much to say about them. I'm using Phillips, these ones, and slotted like these ones. And on one hand, you have these more model-friendly sizes, and on the other hand, you have the regular sizes that you would get in your local hardware store. So, by the way, my tools are all made by LEGENDARY. Again, this is just personal preference, so you can use any brand. But as for me, I like it when all tools are as uniform as possible, so I avoid switching brands throughout similar tools. So the slotted ones go from size 1.5 to 3, and the Phillips ones go from size 00 to 1. Next comes a very important point. It's about hexagon socket screwdrivers and wrenches. You will use them quite a lot during the build of the model, especially the small size of 1.5, since this one is used for M1.6 and M2 screws. So these drivers come in 3 different versions. On one hand, you have the regular Allen wrenches, and then you have the screwdrivers with the straight tip and screwdrivers with the ball tip. So the ball tip is especially important if you can't put the screwdriver on exactly straight. However, you cannot apply as much torque as with the other variants, especially for the small sizes like 1.5. Let's stay with the hexagon. Very important also sockets in small sizes like approximately 2 to 5.5. And they are perfect for screwing in such small model screws. Like this is an M1.6, and therefore you will need an 2.5 socket, and you can perfectly use them together. Also, the larger ones like 5.5 and upwards, we will use them quite a lot once we start doing the hydraulics. Next, we come to the subject of pliers. A normal pair of needle nose pliers like these ones are never wrong, and I think you will always know when you need them. But I much prefer to use these pliers. These are parallel pliers or plier wrenches made by Knipex or Knipex as we call it. They come in different sizes. So this is the version 150. And this would be my regular go-to size for most tasks. And then you have this quite tiny version. This is the 125 version. And for the more rough parts or for the bigger parts, you have the big version. This is the 250 version. And so why are they called parallel grippers? when you have a close look at the jaws, you can see that there is a very parallel movement, and you can change the general size of the pliers by pushing the button. And this is quite perfect when you want to press in a bearing or something like that, and you can make a tremendous amount of force with these pliers, so don't underestimate them, even if they are small. So I rather discovered them by chance, but now I can't work without them anymore. So the unfortunate side is that they are rather expensive. So if you only want to buy one, I would always recommend the 150 version, because you can do about 95% of the task with this version. So of course, links are in the description, and yeah, I only can recommend these sort of pliers. So as the last area of pliers, of course, we have some side cutters, and there again I have a small version like this one and a more coarse version for the rough parts. Also, the small one is intended to use with electronics, like cutting some cables and only small metal parts, and this is always very, very handy. Next, let's move to drilling, reaming, and tapping. So first of all, a set of taps is really super helpful. With the model, of course, all threads are already there, but especially for the small threads like M2, it's always better to remove the paint before the installation of any parts. So personally, I always retap the threads of M1.6, M2, and M3 to remove the paint prior to installing any parts. So that makes it much easier. So this, for example, is M2. Of course, for all international viewers, you have to use metric tabs, like also for the screws, they are all metric, and you can do this the removal of the paint super easy with your small cordless drill. So having a set of small tabs at hand from M1.6 to M3 is really a big recommendation. So I don't have to say much about normal metal drills. It's best to get a set of drills from 1 to 10 millimeter for building such a model. It should be at least in 1.5 millimeter increments. Better are even 0.1 millimeter increments, at least for the sizes 1 to 5 millimeter. But let me advise you, take good drills right from the start. There's the saying of cheap drills make expensive holes, and I only can underline it because you have so much work to do when you break a drill, especially a cheap drill like these black rolled drills. So use ground drills like this one from the start. Now let's look at reamers. Reamers, unlike drills, are not for making holes from scratch, but for widening existing holes very precisely. So you need them in model making, for example, for the holes of the bolts in your model, and of course in the model all holes that need to be very precise are reamed, but just like the small threads, it's quite important to remove the paint before you try to install any bolt of it. And when you use a regular drill, the chance that you would damage the hole is quite significant. So I would always recommend to use a reamer instead of a regular drill. There are generally two different size of reamers. On one hand, you have the hand reamers like this one, and on the other side, you have the machine reamers like this one. You can always recognize hand reamers by looking at the back. So you have this square back right here. And as the name suggests, they are intended to use by hand. For example, with a tab wrench that you would use with your tabs. And but of course you can also use this style of reamer with your cordless drill, like for the lazy among you. And to be honest, I don't exclude myself at all. I personally also use this quite often with a cordless drill. The main difference in the shape is also that hand reamers have are tapered towards the top, so you have a slightly smaller diameter at the top and the regular or nominal diameter at the bottom. So this makes it easier for you to insert the reamer in a hole, because you start at the lower diameter and go to the bigger one. But on the other hand, you can only ream through holes. A machine reamer, on the other hand, usually has the same diameter all over the length, so you could also ream like fractal holes. And machine reamers also don't have the square back on the end. For this model, I will probably only be using machine reamers, and I will use them only in the sizes of 4 millimeters for the bolts of the rollers and 8 millimeters for the bolts of the boom. And I think if you get these sizes, you are pretty good to go. So I briefly mentioned the cordless drill, and I think a small and lightweight cordless drill is a must-have when building such a model. I personally use this Bosch GSR, sorry, and it has 2 speeds. Like, you can select the gear ratio at the top, so you can go very, very slow. This would be perfect for reaming of holes. And of course, you can also go very fast. And this is perfect for drilling with quite small drills. So finally, in the area of material processing, we have some metal files. I also think there is nothing too much to say about it. I use a set of some small files like this one, and also your regular size files that you will get in your hardware store. So having a good quality set of files at hand is always recommended. So last point before we finally get started, let's talk about chemicals. First, let's take a look at these 3 products from Loctite, and again, personal preference. Of course, you can use comparable products. However, I've gotten along quite well with these 3 so far, so Loctite for me it is. First of all, you have the Loctite 243, and this is your regular thread lock, and it should be used on screws that should not get loose by themselves. So if you have some parts that are frequently in motion or subject to vibration, then you should always use a thread lock like this, and this prevents your screws from getting loose over time. Quite similar is the next variant. It's Loctite 648. It's also like the blue variant for tightening or preventing parts from getting loose, but this one is much stronger. So you can use this, for example, to glue gears to motor shafts, and don't ever use it for screws, because you will never be able to loosen them again. So only use it for connections that you generally don't want to come loose again. Of course, you can loosen them if you really have to, for example, by warming up the parts with a flame, but it should more or less happen only in emergency. So last, this is Loctite 542. This is the red one. This will be super important once we get to the hydraulics. So you can use it to seal the hydraulic fittings, and it is more or less a liquid seal that hardens over time. And yeah, we'll see how to use it once we reach the hydraulics, but also you definitely need this. And last in line is your regular super glue. I don't have anything right here to show you, but I think you also have super glue at hand right now, so you will need it at some point. And finally, the last part would be your regular degreaser or brake cleaner. And this is also very important when we reach the hydraulics. And again, the brand doesn't matter that much. We tend to use this brand, but of course you can use anything else. But when using something else, please don't use anything that is too aggressive. So it should dissolve oils and grease to remove like hydraulic oil and grease you don't want to have. But when it's too aggressive, it can attack plastic parts and the paint. So take care of choosing the right one. All right, a lot of tools, but I think that was all for now. If there are any special tools, I will show them during the build-up. And now let's finally start with the assembly. So let's actually start building something. As you can see, first of all, I've swapped the cutting mat on my table to a piece of carpet. So if you have like an old piece of carpet or a small cutout of carpet laying around, I would highly recommend to place it on your table because it prevents the parts from getting some scratches. For every assembly that I do, I always recommend to take a closer look at the parts before you take any screw in your hand and putting some parts together. So let's remove all those parts and concentrate on the main steel construction. So first let's admire the details of this construction. This one, of course, as everything on the model, is exactly modeled after the original data of the machine. So this is the undercarriage of the R960 SME. The undercarriage itself is completely made out of stainless steel. And it's very rigid. So it isn't made like out of a single piece aluminium and just fell out of any CNC mill. It's actually soldered, micro soldered by hand in Germany from professionals. So as you can see, we have all the different steel parts. Like I said, everything is soldered together, welded, micro welded together. It's very durable, like it's indestructible. You can, without any problem, stand on it and it won't deform at all. As you probably see, this isn't the standard Liebherr color. I've chosen a light gray for this excavator, but it doesn't matter at all. So let's get on to it. The first thing I always recommend before doing any assembly work is to take a close look at the piece itself, like we already did, and check if there are any threads or bores where you will need to remove the paint from. Like I showed you the thread cutters just before, we have some threads on the side, like here and here, or a bore here where a dull pin goes in, and it's the best to remove the paint before you do something. So all these holes, this is M2, so we will need our M2 thread cutter, and because there are quite a few holes, also all these holes are M2, of course I won't be doing this by hand. I will be using my cordless drill, so it's really not that much of an issue. Put in the thread cutter, but one thing you should always do is turn it down to the lowest torque possible. So you see I can, without any problem, hold it, and that prevents from breaking the tab. So I will quickly show you one here. Of course, you do need to hold your drill very, very straight to the hole, and then just bore in and you have the paint removed. So if you do it a bit angled, so as you just could see, the clutch instantly like breaks, and this prevents you from breaking your tab. Of course, you should always see that there is no dirt in the tab, and so you can remove the paint from all the holes, and it makes it quite easy to put in the screws. So 4 of many holes are done, and so the next thing I want to show you is how to ream some holes. For example, this one, there will be a dowel pin put in, so this hole should be quite precise to prevent any play of the pin in the hole. We'll also use our cordless drill for it. I've swapped the M2 tab with a 3mm reamer. It's important for reamer that you always go very slow, otherwise you will dull the reamer quite quickly. You can go a bit higher on the maximum torque because a bit of torque is required. So just put it on in a perfectly right angle, then slowly now just remove the paint, and obviously some metal was also removed, but that's totally okay. So now I suppose you can't see it that well, but we do have a very accurate hole, and we could put in the 3mm bolt that will need to go in there, and that makes it much easier if you remove the paint before. So for this hole, you could also use like a regular drill, because this is no part where you have, where it's important that you don't have play between the parts. But for all holes of the like boom, I always recommend you to use a reamer instead of a normal drill. So let me quickly repeat this process for all holes, and then we'll see how it goes on. So for the underside, we also have quite many M2 holes, and I recommend to like recut them all. These are all the holes where you will be moving the track guides and the rollers and so on. We also have some bigger holes that are inside here. These are M3 holes, and they will hold the plate that is put on here. I also recommend to recut the M3 holes. So let's quickly go through it. So to recut the threads by hand, you could use something like this. And this is a small holder for tabs. And this has the square where you can pull in the thread cutter or the die. Just put it in, screw it tight, and then you can recut the holes by hand and have very precise torque because you're using your hand. So that's the other way to do it, and I would recommend you to use one of these if you're not that familiar with using the cordless drill. So as the first step of the assembly, we will be putting in the guides for the track roller at the front. So these are all aluminium parts, and they just get screwed in. So by the way, these are screws where you could use Loctite, but it's more like a personal preference. I don't use it because I don't think that these screws have like that much alternating force when they are used, or when the model is used. So I simply don't use Loctite here. So as the next part, we will be mounting the rollers that sit over here. They hold the track up when the track is moving, the upper part. So as previously mentioned, you should have reamed these holes because they will be put in a dowel pin, and this is a very, very tight fit. So first let's try if the pin fits inside the roller. So that's really not an issue. If it doesn't turn freely, you should also ream the roller, but since it isn't painted on the hole, you should be good to go. So you can simply put in the pin like so and push it in. So this is a part where the parallel grippers will be very nice to use. Just push in the dowel pin and you're good. So as you have seen, I didn't use any glue or Loctite or something like that, since the bolt fits in very tightly here. You should be good without using Loctite. Of course, if you would drill the hole quite a bit bigger, you should simply use the blue Loctite to lock the bolt in place. The next part that we will be mounting are these aluminum parts, and they are the counter blocks where the spring from the from the tensioning roller is put against, and these are some threads where I will be using Loctite, because when you have the spring moving back and forth, the force on this block changes always. So this is a good example where screws will get loose over time, and therefore I will be using the blue Loctite. So first of all, let's put in the block. So this one, will be placed here. And for me, the easiest way to apply Loctite is always to put a little bit of it. Well, obviously, this was quite more than we need. Like on a plastic bag, and then simply take your screw and ever slightly dip it in. So you won't actually need much Loctite. And then just mount it. So as the next piece, we will be installing the pre-assembled track motor. Just take a look at it. This beautiful foul harbor drive. So this has quite much torque to it, and you will get a very, very steady drive out of these industry grade motors. So to make it easier for you to connect the wires for the motor, I would recommend to install the rotary feed through, which is this piece, before you install the motor. So what's it used for? Of course, if you turn the upper carriage later on, you will need to feed through the electric connection, and this is done by this piece. As you can see, you have two pairs of cable going in, red and green and black and yellow. You don't need to remember what cable you do connect to which motor. For me, I always use the red cable for the right motor, and all other colors are quite self-explanatory then. So you have this pair, red and green. So obviously I use this for the right track drive and the others for the left. So use the green and red for the right drive and black and yellow for the left. And now the big prize question, on what side is the right side from the undercarriage? So this is the end where the track drives will be installed. Like this will be put in here, but is this on the left side or the right side? Like now it's the left side and now it's on the right side. So for track drives, it's always so that the motor is at the back. So this is the right side. The Touras wheel is always at the back. I really don't get it why on most pictures in all web shops of like scale models, the model is placed like so that the boom goes in this direction and the Touras is somehow at the front. The Touras goes to the back. The drive is always at the back. So this is the right side. If we turn it around, the red cable needs to go in here. So remove the motor and you can see, probably can't see, but there is like this hole here. You will need to feed the cables through here. So take the feed through, and for some models we also apply these connectors, so you don't need to solder the cables to the motor. Obviously they need to be placed here. If you don't have these connectors, it's not that big of a deal. We don't mount them if the cables of the feed through would be too short to apply them. So the bigger part goes to the top, the thinner part goes to the bottom, and obviously we need to feed through these cables. So here they are. It's a bit fiddly, but I think you will manage it. So with this done, you can install the motor. But actually, before we put it in, we can install the bracket. So if you have the track drive here, simply take the cover, slide it on like so. And for my model, I needed to remove some of the paint inside here because it didn't fit right from the start. It depends a little bit on the color of your undercarriage. Since this is a very bright color, obviously there needs to be put on some more paint than if you have a dark color. So if you need to remove the paint, simply take a file and remove the paint from the inside, like here and here, and you should be good to go. So it's on here. Now we need some screws. So simply slide the motor unit in. Obviously, I just noticed that there is some color in the threads, so it will be easier if we remove the color first. So the cables don't go all the way back to the motor. Let me show it right here. So that's how they connect. And you can always disconnect them in case you need to unmount the whole assembly. So that's why it's better to not solder the cables to the motor. Also for motor, I will use the motor again. So, and that's it. We have successfully assembled the first parts of the undercarriage. And this pretty much wraps up this first episode of the assembly of the LEGENDARY R960 SME.